Hi friends, welcome to this video. So in this video I am going to discuss about the KCET 2018 from the question 26 to 30, right? So the question is, phenol can be distinguished from ethanol by the reagent, right? So they have given this is phenol you know, right? So here this is benzene ring. To that, if OH is directly attached, that is nothing but the phenol. And this is ethanol means CH3 CH2 OH, that is nothing but ethanol, right? So how can we distinguish both, right? So chlorine water, this C D option, chlorine water we can't distinguish. Why we can't distinguish? Because chlorine water is colorless, so this is not the option. Iron metal, nothing it can do with this both the reagent. Sodium metal, so sodium, if I treat with this sodium, it will also react, it will form phenoxide anion, sodium phenoxide, and this will also react with sodium and it forms CH3CH2O minus Na plus. It is a strong base, so both will react, so we can't distinguish. So this is also not the option. So B is not the option, C is not the option, D is not the option. Which is the correct option? Bromine water. Why bromine water? Let me explain it. See, this is phenol and here I have what? CH3CH2OH, ethanol. So this bromine water is there, right? Bromine Br2 in water is solvent. So this is yellow color, right? Yellow color. As soon as we put this bromine water in phenol, it starts reacting and we'll get this product: phenol, orthoposition bromine, position bromine, and orthoposition bromine. So we'll get 2, 4, 6 tribromophenol. Whereas the same bromine, if I put it in water, the solution remains yellow color only. It means the reaction doesn't happen. Bromine is yellow, and after if we put both the things, it will also yellow. It means that the reaction doesn't happen. So this is how we can distinguish. So if I have bromine water, so yellow color initially, it reacts with bromine, it becomes what? A different color, or it might be colorless. We have to check it whether it is colored or colorless. So color will definitely change. So initially yellow color was there, here it is different color, so color change happens. Here initially it is yellow, after reacting also it remains yellow. It means it doesn't react only, right? So just this is A, this is B, both will remain as it is only. A, B doesn't react. Here A and here B both have reacted in case of phenol, and we have got different product, that is 2,4,6 tribromophenol. So the correct option is bromine water. So bromine water we can easily distinguish both phenol and ethanol, right? Coming to the 27th question. Which of the following compounds undergoes haloform reaction? So haloform reaction you have studied from the chapter aldehyde, ketones and carboxylic acid, right? So haloform reaction, we add some reagent, that is nothing but the NaOH plus 3 molecules of X2, right? So this is the haloform reagent which act as a mild oxidizing agent, right? So this will be reacting with only such molecule like secondary alcohol, or ketones or aldehydes having this CH3 molecule here. Alright, alpha, so this is the functional group, ketone or the aldehyde. Next carbon should be alpha carbon, it should have 3 hydrogen, then only this reaction happens. So see what happens. So if I add NaOH to X2, it acts as an oxidizing agent. So secondary alcohol will be converted to ketone. Here it is converted to acetone. Further, if I add NaOH and I2 molecule, 3 molecules of I2, I'll get this product. This is oxidizing agent, right? The ketone will be converted to carboxylic acid, COO minus and Na plus, carboxylic acid, salts of carboxylic acid. And this CH3 group was there, right? CH3, it becomes CHI3 now. CHI3, which is nothing but the iodoform. Which is nothing but the yellow crystals will be there. Yellow crystal, and smell will be very sweet smelling liquid. The sweet smelling it will be. Sweet smelling. right? So from this we can distinguish whether the ketones or the aldehydes containing alpha carbon which has 3 hydrogens. If 2 hydrogens are there, then also we won't get this isoform. Only 3 hydrogens should be there, then only we will get this isoform test, right? So this is isoform reagent, and it will be given by secondary alcohol as well as ketones or aldehyde which containing alpha carbon should have 3 hydrogens, right? So see, here I have aldehyde, it doesn't give any aldehyde, right? And here I have ethyl bromide, right? This also doesn't give hydroform test. This is ether, ROR, ether, CH3O, CH3. This also doesn't give. So correct option is this one, CH3CO, CH3. CH3CO, CH3 is nothing but this CH3CO, CH3. That is the acetone. Same thing I have done, right? So this will give hydroform test, right? So 27th answer is A. Coming to the question 28th, which of the following will be the most stable diazonium salt? Rn2 plus X minus, right? So diazotization, let me explain it. So here I have benzene ring. To that, if I attached NH2, that is nothing but aniline. That is nothing but the primary amine. Only primary amine will give diazotization in presence of NaNO2 and HCl. It will form HNO2, nitrous acid, or it can also be written as HONO, right? So this will be stable only at 0 degrees Celsius, 0 to 5 degrees Celsius, right? So reaction happens between them and we'll get this product. Aniline, it converts to N2 plus, and here HCl I have added, so I'll get Cl minus. This is nothing but the benzene diazonium chloride, right? Benzene diazonium chloride, BDC we call, right? Which will be colorless, liquid it is, right? So this is stable. Why it is stable? Because see, so if I draw the structure of this, it will be like this. Benzene ring will be there. Diazonium means N triple bond N plus and Cl minus will be there. So this plus charge will be stabilized by resonance like this, right? Because of resonance stabilization, this is stable, that too around 0 to 5 degrees Celsius only, right? If I have anything like CH3, CH2, NH2, primary amine, right? This is also ethane amine. To this, if I add this HNO2, it will directly convert to CH3, CH2OH. I'll get alcohol. I won't get this intermediate CH3, CH2, N2 plus Cl minus. This intermediate will be there, but that will be unstable. Why it is unstable? Because here no resonance stabilization as in benzene. Here resonance plus R effect or plus M effect stabilization happens. Here no plus R or no plus M. Only plus I effect is there, inductive. So it is unstable. Directly we will get what? Alcohol. Right? Directly we will get alcohol. So here we can see C6H5N2 plus Cl X minus. So this will be stable. Other things, this is highly unstable, this is also unstable, and this is nothing but the C6H5. D, option D is nothing but the C6H5 CH2 N2 plus X minus, means this is also unstable. If it goes, sorry, just a minute, if it goes, I'll get carbocation, right? I'll get what? Carbocation, which can be stabilized, right? Right. So here the benzene ring, see, just a minute, let me explain it. So here what we have, here I have aniline which converts to N2 plus X minus, whereas in the option D, that is nothing but the CH2 N2 plus X minus. See, plus is away from benzene, it is not stabilized by resonance here. No plus R nor no plus M. But here plus M or plus R, both effects are there, right? So this is stable. So option what? Option B is the stable product. Option D is also not the stable product, right? So this is about question number 28. Coming to question number 29. So which of the following bases is not present in DNA, right? So DNA has bases. What are the bases? Bases, it has got A, T, G, C, adenine, thymine, guanine and cytosine. These are the bases present in DNA. Whereas in RNA, the bases, it has got same A, G, C. Three bases are same. Instead of thymine, I will be having uracil. In RNA. So the question is, Which of the following bases is not present? Not present in DNA. So in DNA, uracil is not present. It is present in what? It is present in RNA only. So option D is the correct option, right? So this is from the chapter biomolecules. So coming to question number 30. Which one of the following is a polyamide polymer? So polyamide means it should have linkage this one, C double bond O R H. Right, here chain continues and here chain continues, right? So it should have this amide linkage. This linkage we call it as amide linkage. So in polymer chapter we will learn that. In polymer chapter we will learn about polysters which have got ester linkage that is nothing but chain here, C double bond O like this, chain continues. So ester linkage, such polymers we call as polysters. In that we will discuss about terline we will discuss about, and glyptal we will discuss about glyptal. Whereas in polyamide which have got amide linkage as shown above, which has got amide linkage, their amide linkage, there we discuss about two polymers. One is nylon 66 and other one is nylon 6. So these two have got amide linkage. So nylon 66 is the example. But still in biodegradable polymer we will be having both. A polyester polymer is PHBB, poly beta hydroxybutyrate, co beta butoxyvalerate. It has got ester linkage. Whereas nylon 2 comma nylon 6 has got amide linkage, so these things also you have to remember. In biodegradable also we have ester linkage and amide linkage, whereas this sterling has got here ester linkage, nylon 6 is no doubt amide linkage, so this is the correct option. Bunias is nothing but the copolymer of rubber, right? Synthetic rubber. There you will learn about Bunias. Bakelite, it is a condensation polymer which will be having cross linking like this, right? So this also you have studied in the chapter polymers, right? So this is about the question number 30. Thank you.